So here we are, pretty much at the end of the Object-Oriented Programming 2 section, and ready for the knowledge review. We've got all of our concepts out of the way, and we're ready to see how well you understand them. But the knowledge review is going to be a bit tricky this time around, as you're going to be developing your first true program. So before jumping into the knowledge review, we thought it would be quite nice to see an actual implementation of a lot of the concepts that we have provided to you through Object-Oriented Programming 1 and Object-Oriented Programming 2 in a simple XNA application. Now, this application is not going to be a full-blown game. As a matter of fact, it's not really going to be a game at all. We are going to have game items, if you will. We're going to have a couple of enemies and a player that's going to run around the screen. We will be using XNA, and while we've yet to provide a formal introduction to XNA, we have taken a look at it and utilized the XNA framework back in Canon 3. So this is going to be nothing really new. The idea is just to focus on exactly what we're doing with the classes. We're going to be looking at things like static constructors, a static list, inheritance, polymorphism. We're going to try to put a lot of the things that we've looked at all into this one application while keeping it as simple as possible. Now, when we start getting into some of the tracking code, we're going to use a little bit of stuff that you may not have seen before, a little bit of vector math. No, the idea of this video is not to start breaking down the math that we're using. We're going to be doing that a little bit later on. The idea is just to get a good understanding of what we're doing with the classes. So when we get to the area, Logan will explain it and we're going to move on. Just keep that in mind. So with that, what is this small XNA application supposed to do? Well, let's go ahead and draw out a window. Let's draw an enemy. Let's draw a player. We're going to have a player. The player is going to be able to move around the screen. Now, we've yet to introduce the Xbox controller, so we're going to do this through keyboard input for the time being. So you'll be able to hit the up, down, left, and right keys, and your character will simply move around the screen. As you're moving around the screen, the enemy's job is to constantly chase you. Simple enough. But we're going to add a second kind of enemy that is going to be based on the first enemy, and he is also going to chase you, but he's going to have a bit of a problem. He's what we call a drunken enemy. So instead of coming straight after you, he's going to more or less weave after you, kind of like one of these. It's going to be an interesting effect. So the very first thing we need to know is, what are our requirements? Well, we need a player that is keyboard controlled. We need a standard enemy that is always moving towards a player. We need a drunken enemy that is kind of moving circular, if you will, towards a player. Now, we want to keep everything in a list. So basically, we're going to have actors. And we're going to need an actors list. So inside our actors list, we could have a player, an enemy, and a drunken enemy. Because as you've seen, it's very handy being able to loop through a single list, and inside that list have objects of different types, such as players, enemies, etc., and just say, look, actors, call upon their update, and just have that take place for you. So we want to get a scenario set up here where everything is somewhat automated, if you will. We create a player. The player is automatically added into the list. We create an enemy. He's automatically added into the list and takes off after the player. You get the idea. Now, with understanding that is the basic application that we're going to create, we need to take a look at how we can generalize this so that we can break it up into classes. Well, first of all, our general observations include the following. First of all actors are going to need a texture. So I'll just put actors need a texture. All actors are going to need a position. All actors are going to need to be able to update. And all actors are going to need to be able to draw themselves. And since these last two things are behaviors, let's go ahead and mark them as such. Okay, so that's pretty much everything that I can think of for the actors. Now to get a little bit more specific, what's the player going to need? Well, he's already got a texture. His position's going to come from you interacting with the keyboard. He's already going to have an update because, well, we're going to derive it from actors, and he's going to already have a draw thanks to actors. So player's pretty much taken care of. That's convenient. How about the enemy? The enemy is going to need to be able to seek the player. So the enemy is going to need a little bit of special functionality going on here. So the enemy needs to hunt or seek player. Now let's see, where can we do this? Where can he hunt or seek the player? How about simply inside update? I mean, it makes sense. Every time we update, find where the player is at and head in that direction. So we don't need any other special type of method sitting out there. We just need to add this into update. Now, of course, we don't want to put the code up in update because player is going to inherit from update as well. And if we did that, now the player is going to want to seek himself. Probably not a good idea. So we'll want to make update virtual so that we can override it down in enemy. All right, so that's sounding pretty good. That means enemy is also going to need a target. So when he's hunting the player, he's really, I'm going to change this now, hunting a target. Yeah, that'll work. And so the enemy is going to be given a target, and then during update, he knows that he's going to need to hunt it. Excellent. All right, what else do we need? Let's see. Enemies. Thinking about it, that's pretty much everything from enemies. Now we got a drunken enemy. So now we're going to get a little bit more specific. So let's see, this drunken enemy is going to do everything that the enemy is going to do, except he's going to need his hunting code or seeking code modified in some way. He still needs to find where the player is at and head that direction, but he needs a little extra manipulation to give him a drunken type effect. So let's see, how do we want to put this? We'll just put adjust hunt.
Or you could say that the drunken enemy needs to stagger as he's hunting.
Just hunt with stagger. Nice. With stagger. Does that work for you?
Yeah, that's cool.
All right, very nice. So this means that we obviously don't want to lose the behavior that's an enemy because we've already got the enemy heading towards the player. So we need drunken enemy to do that. He just needs to stagger as well. So we will override enemy's override version of update, and we'll call upon enemy's update behavior and then add to it so that we can further manipulate our path as we head towards the player so that we end up with one of these type effects. Okay? So, that looks pretty good. Now, if we take a look at this general observations list that we've just created, how can we go ahead and derive our classes? Let's go ahead and do that. So I'm going to give myself a little bit of room here. Scroll on down. Well, obviously everything is going to be an actor. You know what, actually, let me just delete that out and give myself a little bit more room because I'm going to do a little bit of writing over on the side. So I'll start out with an actor. Actor is going to need, well, he's going to need an actor list. So that we can store all of the actors in it. That list is going to need to be created. So we'll need a static constructor to do that.
And we'll also end up making the actor list itself static. So that way we have one static actor list throughout all actors.
You don't want one that's instantiated with each instance of actor. That, well, wouldn't be good at all. So a static constructor. And we'll say, we'll go to create actor list. Okay, let's see, what else? Obviously, we're going to need a public constructor. Why would we want a public constructor? Well, taking a look at our list, we said that they need a texture, a position. Let's see, in this case, we don't need to actually give a position. We can just have him start at 0, 0. That's really kind of irrelevant. Now, the player will position him somewhere. But we definitely need to get a texture up there. And we need to also get the new instantiation of the actor added into the list. So that's a great time to do it. So how about we pass it a texture and add to list. Now let's think about this. How nice is that? When we create a new enemy, of course, the constructor and enemy is going to have to call up to the actor's constructor. As we've seen in the past when we deal with inheritance, we also have to deal with constructor chaining. That's just the way it goes. So then, obviously, when creating the enemy, we're going to need to say, here is the texture that you're going to use. And then the actor says, well, thank you very much for that texture. And let's go ahead and add ourselves into the list. So now at this point, when we start walking through the list, this newly created enemy is just there. How convenient. Okay, so that'll work for the constructor. Let's see, what else we have? Well, now we've got update and we've got draw. So let's get these guys in there. So we'll need a virtual update. And we know that we need virtual update for the simple fact that we've already said in the list that enemy needs to have specific seeking code in his update. And, you know, later on in time, maybe the player is going to need something in his update. By putting update up in actor, every class that inherits from actor will have an update method that we can go in and add code. Later on, the player might need some. In this particular case, we're keeping this simple. He doesn't, but it's there for future expandability. So virtual update, what's going to go in it up at the actor level? Nothing. Empty. Okay, we're just setting ourselves up a framework, if you will. And then how about a draw? So we'll put in a public draw. And the idea is to draw itself. Look pretty good for actor, Logan?
Yeah, that's pretty much the framework that all actors are going to need. That doesn't make actor into anything specific on screen,
nah,
but it does provide the base framework that all the actual game or all the actual things in the game are going to need. They're all going to need to be in a list so we can manage them. They're all going to need to have constructors which put them in the list. They're all going to need update because that's where we specify things that the actors actually do while the game is running, and they're going to need to be able to draw so that we can see them.
Exactly. Let me go ahead and throw in. That was going to bother me. All right, there. I went ahead while he was going over the list of requirements again for the class. I went ahead and jotted down the two fields that we'll need, of course, texture and position in the actor. So that, of course, every actor has a texture so that we have something that we can see on screen, and every actor has a position so we know where to draw that texture at. Okay, now let's start with the easy one. Extending actor into a player. So over here, we have our player. What is player going to need? Well, player just needs a public constructor. I'm just going to draw it as open and closing parentheses, but we already know that obviously he's going to need to take in a texture so that he can send this texture on up here. Okay, because the public constructor on the actor is going to get called, and he is expecting a texture to come in so that we can set the texture field in the actor. So the player is going to need a constructor for that simple purpose. Let's see, what else? Player. Player's not going to need anything else. We're going to just handle input control over inside the XNA's game class where we've got the update taking place. We'll pull for keyboard input and we'll adjust the player's position, and then update will run for the player. Well, at that particular case, he's going to end up getting drawn wherever his position's at. So player, that's pretty much it. Now, extending in the other direction, we've got an enemy. Now, what does the enemy need? Obviously, a public constructor. And once again, he's going to obviously need a texture. But what if he also got in a target? And we could probably go even further and add in a, I'm just going to wrap this around, guys, and a speed. So now we could say enemy's going to go this fast. He's going to have the texture. The texture, once again, is going to get passed on up to the public constructor back up in actor. And then the target, that doesn't need to get passed up to actor because all actors don't need a target, only enemies. So the enemy can then set its target with the target that is coming in, which of course will be an actor, which in the end will be our player. Though we could set the enemy to chase another enemy if we wanted to. That's kind of the cool thing with the way this is being set up. And only one other thing needs to go into the enemy class, and that's going to be an override update. And inside here is where we're going to have our seek code. Okay, so this is where he's going to be seeking the target that we tell him to seek. All right, simple enough. Now, from enemy, we'll derive a drunken enemy. And what does drunken enemy need? Well, drunken enemy is going to obviously need to also override our update. So that we can, well, let's just say modify or expand or extend. Extend works good. Modify the seek code.
Yeah, it's basically going to modify his behavior somewhat from a normal enemy.
Yep, exactly. And of course, we're going to be constructors involved in the fact that we need to send in a texture and all that good stuff. So, there we go. Look pretty good, Logan?
Yeah, it looks fairly straightforward.
I mean, just a general idea. We're trying to keep this very simple. We really are trying to simply anchor down the concepts applied here in an object-oriented programming. Because in the knowledge review, what we are going to present is going to be a challenge that is going to require a bit of thinking. And you're going to need a solid understanding of what's happening in regards to the fundamental levels of object-oriented programming. Okay? So, with all of this out of the way, I think we're pretty much ready to rock and roll. So, Logan, I'm going to turn it over to you. If you want to go ahead and bring up Visual Studio.
All right.
Let's start out with a new XNA game.
All right, so we'll start out with a new Windows game. And what do we want to call this? Just actor demo?
Yeah, that sounds good. Actor demo, actor management. Either way, sounds good. And let's go ahead and load some textures in that we can use. Right.
We're going to need, obviously, textures so that we can see each of our actors. Actors take in textures. And I have prepared some textures in this folder. We have a texture for player, drunken, and enemy.
Oh, and they're sophisticated. Logan spent a whole whopping 30 seconds putting all three together.
So we're going to need to get these textures placed into our solution. I'm going to begin by adding a folder to hold textures. So I'll drop over to the actor demo project, and then we'll add first a new folder and call it textures. And by doing this, if we look at the actual projects folder, as a matter of fact, if I save all this out, and then jump over to the project folder. So here's our Visual Studio project folder. There's our new actor demo. And inside of that, we now have a textures folder, which would be a very convenient place to simply copy all of these textures to. So I'm grabbing all of my source art textures, placing them in the textures folder underneath the project folder, so that I can go back into Visual Studio, and then we'll add some existing items to the textures folder from inside of Visual Studio. So here we have our folder, our textures folder, and if we drop our types of files down to content pipeline files, there are our three textures. I can select all of them and add them into the project.
Very nice.
So that gets step one out of the way. Now when we get around to drawing things, we have all of our source art available.
Okay. Very good. Now, do you want to go ahead and start out with some classes?
Yeah, it would be a good idea to get the class framework in place.
Agreed. So, based off the drawings that we did over on the whiteboard, let's go ahead and start with our actor class.
All right. And for keeping all of our actors neatened up, I'm going to make a folder for all of them, just like we've done in some past lessons by making a classes folder. And then into that classes folder, I'll place a new item. We'll make sure that class is selected, and this will be our actor class. So there we have the actor class. Now it is going to try to append to the namespace because it's reading the folder. I'm going to remove that so that everything's in the same namespace. Now we have our class actor, so we can begin fleshing out actor.
Okay, well obviously the very first thing we're going to need is going to be the static list. This list is going to be very important because all of our actors are going to be in this list. And as a quick review, hope you don't mind, Logan, I'm going to jump back over here real fast.
Sure.
Add in a new whiteboard. Just as a quick reminder, we all know that we have the heap. And on, whoa, that's horrible. And on the heap, we get our object type loaded, which is going to be actor. But this is the class. It's off of this that we get instances of things like player and enemy. There we go. Now, this list, this static list, is going to, since it's static, it's going to be maintained over here on actor. So that each time we instantiate actor, like with player and enemy, that player gets added in, the enemy gets added in, so they are added into the list that is on the actor class. So just keep in mind that this list is static. So we only have one of them, which gives us a very convenient place to go and do things such as actor.count, or walk through the actors and look for one, or walk through all of the actors and update them, etc. So just keep in mind, this particular list is not instantiated with each of our objects. Okay? So with that, Logan, go ahead and take it back away. Just a quick reminder.
All right. So that's the first thing we'll need. We'll need a public static list. So public static list, and of course lists are taken a type, and it's going to be of type actor, since this is an actor list. So we'll say list actor, and then let's just call this actors. So we'll have all the actors in the scene.
Sounds good.
All right, now we need some other members. These for specific instances. We need things like texture and position. I'm going to make both of these protected, since we don't want to have any external code having the ability to go in and modify these. We're going to keep it to anything that's descendant only. So I'll make these protected. First is going to be a texture 2D called texture. And the second is going to be a vector 2 for position. So this will be protected vector 2 called position. Now you'll notice that neither of these types, texture 2D or vector 2, are showing up highlighted. This is because we haven't referenced the namespace. We could either reference the whole namespace or simply add a using statement. And we need to gain access to things like Microsoft.xna.framework and then Microsoft.xna.framework.graphics, so we have the texture. So we can add those in as Microsoft.xna.framework and Microsoft.
Vector 2 just came to life.
And there's our vector 2. Now, if we add on to that graphics, there's our texture 2D.
There's our texture. Cool.
All right, that gives us texture and position. Now, let's add a public property because we do need to control the player using the keyboard.
That's true.
And that is going to require accessing and setting the position externally. So we'll make a property to access position. So this will be a public property. It's going to be of type vector 2 because that's what position is. We'll call it position. And inside of this, we'll add a get and set accessor. So get will simply return the position field, and the set accessor we'll use to simply set the position field. So position equals value. All
okay,
right.
So let's go and create the static constructor now so that we can actually generate that static list.
Right, since we need to have this actor list in place before we start trying to add actors to it, that means we need to create it. If we leave it alone now and then later try to add things to it, it's going to be null, which will probably give us some sort of exception.
And null in the fact that actors, which is just a variable that points to a list, the list hasn't been created yet, so it's null, meaning it's not referencing that list. So
exactly.
Just keep the big picture in mind.
We've defined that we can have an actors list accessed through the actors variable. Right now, if we were to just run right here, actors would be null. So we're going to set up a static constructor so that as soon as this actors class comes into oh, whoops, let's say a static, I have to give the name, there we go, static actor.
So as soon as it comes into use, that list is going to be created.
So we can store a new list in our actors reference. So actors equals new list of actors.
Very nice. All right, so now let's go ahead and let's see. How about a public constructor? See, this is an interesting case. We're using a static one to make sure that list gets created, and we're going to create a public one because we need to get a texture in to this actor and set the texture field with it.
Right. So now we're going to deal with instances. So we'll make a public constructor. So public actor. An actor is going to take in a texture. So we need to give it a parameter of type texture 2D, and we can simply call that texture. And inside of this constructor, so now if we're inside of here, we're making an instance of actor. So we need to do a few things, like remember the incoming texture. So we can say this dot texture equals the texture parameter.
Okay.
Then we need to turn around and add ourselves to the static list, so that later we can be managed through that list. So we can say actors dot add this. So that way every new instance remembers its texture and then puts itself inside of the list, so that later when we want to look for all actors, we just look at the list and loop through it.
Okay.
And that should take care of the public constructor.
All right, so now we need the ability for updating and drawing.
All right. We could throw in...
Go ahead and throw in update real quick.
Sure. And this is going to be public, because we need to be able to tell actors to update. It also needs to be virtual, because we know we're going to change the behavior in different kinds of actors. All update is something to alert an actor that the fact that it's being updated, that basically that some time has passed.
Okay.
And an actor isn't really anything yet. An actor is going to be used for things like players and enemies, and those are going to respond in different ways. Where an enemy might go straight to the player, a drunken enemy might have to move in circles on its way to the player. So we're going to define update as virtual. And we're also going to say that it doesn't return anything, so it's void, and we'll call it update. Now I am going to take in a parameter to update. I want it to be able to tell how much time has passed. This is going to become very important when we get to the drunken enemy, because I'm going to use that to calculate the speed of the circles. So what we're going to take in is a type of game time, and we're going to call it game time. We'll actually get this from the main game's own update. We'll see that that's available in the game class's update. And as a matter of fact, I'm just going to put the braces off to the side.
Since it's just an empty method.
Right, since we're not going to implement it in actor.
All right, so the final thing is to draw, and of course we know that back over in game it's our sprite batch that we use for drawing, so we're going to need to pass the sprite batch over to here to handle it.
Right. So I'll take in a sprite batch, and we can just call that parameter sprite batch. All right. Now, we do want to handle drawing. Since all actors are a simple texture drawn on the screen, we'll go ahead and do the drawing from actor, and then in all the descendants, we won't have to worry about drawing code. We'll just let actor handle it.
Sounds good.
All right, so inside of draw, we should be able to use one of the more simplistic overrides of draw for the sprite batch. So we'll say sprite batch.draw. We know we need to take in a texture, and we have a texture, which is in this.texture. We need to draw at a specific position, and we happen to be holding a vector 2 named position. And finally, we need a color to use. I'm not going to use the color for any kind of modification or tinting, so I'm just going to apply color.white so we retain the original color.
Very simple.
And that should be it. So we'll just use one of the very simple overrides, since a lot of the data, matter of fact, most of the data that we have will satisfy spritebatch.draw, at least in this manner.
Very nice. And that is everything that we described back over there with our requirements and the diagram that we drew. All right, very good. So from there, let's go ahead and set player up, because player is just easy.
Sure, this will be
easy.
Really quick. I'm going back to the classes folder so I can add a new item. And still on class, we'll add the player class. So here is our player class. Standard procedure will remove the classes from the namespace, and then we'll address player. Now the player class needs to extend actor. Then inside of the player class, if we try to build, as a matter of fact, I should have built just from actor to make sure I didn't have any syntax errors, so I'll do that. We'll let it build, and good, okay.
Yep.
So actor was fine. This is what I was trying to show here. Of course, we're inheriting from actor. Actor does not have a default constructor, which we're not satisfying the
That's right, because we
constructor with parameters.
explicitly created a constructor that takes in
And that's what that's what you're talking about back in the implementation plan. We're going to need to have player, feed a texture through to actor.
That's right, through the constructor.
So let's set up a public constructor for player. And then in that public constructor, let's take in a texture 2D called texture. And then let's access the base constructor where we feed it
a
texture. So that will satisfy the base constructor, and then I'm just going to put the brackets off to the side from that since we're not going to implement anything else. The only reason we need the constructor is so that players will also take in a texture, and then they can use that texture to apply to the base constructor.
So through the initializer, we simply send that texture on, so that the actor's public constructor can then handle setting that texture.
Right. But of course here we don't have the using referencing graphics.
Right.
So I'm going to steal that from actor, where we're using Microsoft.xna.framework.graphics.
That knows what a texture 2D is.
And now we have texture 2D as a valid type. We can now build, and everything succeeds.
All right. Well, let's go ahead and add the enemy now.
All right. So let's yet again add a new item, and this item will be our enemy class. All right. Once again, we're not under the class's namespace. We have an enemy. Enemies, like all other actors, need to inherit from actor. They'll need a public constructor so that we can, well, not only do the texture, but also take in some enemy-specific things. So let's put in a public constructor for enemy. All right, we need to take in a few things. Once again, a texture 2D. Call that texture. We need to take in an actor as the target. We'll name the parameter target. We also need to take in a speed, so we can say how fast this enemy is. I'll take this in as a float, and we can call it speed. Alright. Now, of course, we need to call the base constructor and pass it texture. And we need to do a few things inside of this constructor, so I'll jump down and put the blocking in. And I could leave that on the other line, but at this screen res, it does happen to fit, so I'll leave it all on one line.
Okay.
All right, a few things we need to set up. As a matter of fact, we need some fields to store these values. We're taking in a target and a speed.
But we need to remember them.
Right, we need to remember those throughout the life of an enemy.
That's right.
So we'll need a few fields. We'll make these private, since this is all these things will be specific to how enemies react. There's, at this point in time, no reason to have anything else use these. So we'll have a private float for speed, and a private actor for target. So with these fields now, we need to initialize these in the constructor. So we'll say our target, our texture, target equals the target parameter, and this dot speed is equal to the speed parameter.
Very good.
And that should take care of the public constructor.
All right, now we need to do our override for update.
All right. So this is a public override void, and it has noticed that update is the one thing that we can override with a void return. So I'll go ahead and let it use update, which will throw in game time, and you notice it threw in the fully qualified name because we have not yet added those into the class. It has also added in a call to base. First thing, let me actually throw this as a using, so we don't have to have the whole thing taking up space on the screen. And with that using in place, I can now take this all the way down to game time, just as we had defined it in actor. Because in actor, we were defining update with game time as available. That's because we were using Microsoft.XNA framework,
which is where it comes from.
So with that in place, we now have game time in a shorter version. I'm not going to call the base constructor at this point because in this case, we know that actor's base constructor is going to do nothing.
Right.
So a call to it isn't needed here. If in the future we start to add things to actor, then we'll need to go ahead and put a base call in.
Sure.
But from here, enemy is the first thing that defines some behavior for update.
Right. Now, let's think about what is the enemy going to do. Well, the idea is for him to get a direction to go and start traveling in that direction. It's as simple as that because he's seeking out the player, or the target in this case. But let's say that for whatever reason, null was sent in. So we want to make sure that we actually have acquired a target to track down.
Right, because we're about to start to reference that target in order to get its positional information.
And if it was a null that had come in, well,
then we're going to try to access a null.
And that's not
problems.
good. Explosions.
So the first thing we need to do is to do a check and see if we even have a target. And this will just be a simple check of if target is equal to null. So if this is the case, then we have no target. And in that case, we'll simply return. There's no reason to attempt to try to find a target in that case. Otherwise, so if target was not null, then we have a target that we can look at and pull a position from. So what we need to do now is we need to come up with a direction from where we are to where the target is. And I'm going to store that in a vector 2. So of a vector 2, I'm going to call it direction. And I'm going to be set that to equal to, I'll add in all of this in 2 stages.
Sure.
First, we just want to get the difference between the target's position and our position. So the direction is going to be equal to target dot position minus our own position, which is this dot position. Now, what this is going to do is give the entire distance between the target and this current enemy.
Mm-hmm.
And if we try to move by that amount, that will, in one update, snap us to the actual enemy. And we don't want to move that quickly. We don't want to move in small increments over each frame. So what I'm going to do is take this entire value, since it's kind of doing 2 things. In a way, you could say that it's pointing from our position to the target, but it's also giving a magnitude.
Right.
I'd rather take that part out, get the direction, or leave the directional information, but have the overall value of this vector be 1. And that can be obtained by normalizing the vector. And I can do that by using vector2.normalize and applying that to the distance that we acquired. So if we normalize this, we still have the relationship between x and y is still the same. The ratio between x and y is the same. But they have been reduced or increased, depending on the scenario, so that their overall magnitude is 1.
So picture a small little arrow that is pointing towards the enemy.
Exactly. So now with this direction, this gives us something that we can move by. So that means we could take our position and we could increment it by the direction. And that will basically move us 1 unit closer to the enemy if we left it alone as simply direction.
Right.
But we know we have a speed. And this is another reason why having a unit vector or a vector of value 1, because that way, since direction is always going to move us in 1, but we have a speed. So if speed was set to 5, we know we actually want to use 5 units. So we could just multiply that by direction. So direction times speed, and now the speed can be set. So no matter how far away the enemy and the target are, we'll always be able to travel towards the enemy at a constant speed, staying the same as we get closer.
Very good.
And
I think that's pretty much going to wrap that up. You want to go ahead and build and make sure everything's looking good.
Sure, we can build, make sure that everything is put in place. Let's see, texture 2D, so I must be missing a reference to graphics.
Yep.
And yep. So I'll simply paste this one again so that I can access framework.graphics.
All right.
Now if we build, everything is working good for the enemy.
All right, now we were going to further extend enemy into a drunken enemy.
All right, so once again, back to classes. We'll add a new item, and we'll call this drunken enemy. And I want to have a capital letter for enemy. So drunkenenemy.cs will be our source file. We'll have a drunken enemy class. Once again, removing the classes from the namespace.
Okay.
And just because I have a
jump
feeling,
over and cap. Yep.
just have a feeling that we're going to end up needing these, so I'll drop in references or using statements for Microsoft.XNA framework and for graphics.
So let's go ahead and start out, of course, with a public constructor that's going to need.
Even before that, let me go ahead and
and inherit.
So drunken enemy now inherits from enemy, because of course we want to keep all the enemy behavior we have so far.
That's right.
And extend that a little bit.
That's right. Now let's throw a public constructor in there.
All right, so we need a public constructor for drunken enemy.
And of course he's going to need to send everything up that is required by enemy, so we're going to need to send a texture, because actor in the end is going to need that. We're going to need to send a target and a speed.
All right, so we have a texture, and this being an enemy, we need a target, so we'll need to take in an actor. And again, we can call this target. And a float, and this is our speed. Then we want to call the base constructor, passing it everything. Texture, target, that's 18, and speed. And in this case, if it wants to throw the base
That's fine, yeah.
constructor on another line, we've already exceeded our width there, so that's fine.
And that's all we really need here, because everything's going to be taken care of by the enemy's constructor.
Right. There's basically, since we're not changing any of the fields or adding fields, there's nothing for us to initialize or otherwise change. So with that in mind, I'm actually going to take the brackets and put them on one line, just have it for things that don't have code in them.
All right, so let's see. At this point, all that's really left is just update. We need to override update yet again and add some circular behavior to our tracking code, if you will.
Okay. So let's start on that. We want to add the ability to move in a circle. To accomplish this, I'm going to use sine and cosine.
Okay.
So we can have one direction. Say we could have x controlled by sine, so he'll move back and forth on x. And then have y controlled by cosine, so he'll move up and down on y, but offset, so that we end up with a circular motion instead of a diagonal motion.
Okay.
So we need to do this inside of update. So let's do a public override void for update. And in this case, the base, calling the base's update is very important. Base's update is what gives us our direction or our movement towards the target.
That's right.
And that is, well, required.
Yeah,
so
because we still want the drunken enemy to slowly make his way towards the actual target. So this just moved him one step closer to the target.
All right. Now we need to define our own behavior for moving in a circle. I'm going to record this offset or this circle movement as an offset so that we can then turn around and apply that to our current position. So I'm going to make a vector2 to store this offset, and we'll initialize it to 0. So I'm going to set it equal to vector2 dot 0, and this way I can access its components. Otherwise it wouldn't be created yet and I couldn't increment it. So we're starting off with a vector2 called offset set to 0, 0. Now we need to come up with our actual offsets. We can begin with the offset in x. So we can say offset.x equals math.sine, and we'll have the sine calculated as game time progresses. And this is why taking in game time is important.
Because we need something that's constantly changing.
Right. We need, in order for the sine to progress, it's almost like we have to animate it against an increasing value.
Yeah, you do.
One value that increases continually is the total amount of game time that has been recorded. If we keep watching that value grow and keep applying sine to it, then we'll get a consistent sine off of time.
Precisely.
So to gain access to this total time that has passed, we need to look into game time. We need to access total game time. And from that, we want to get out the total time in seconds. So I'll grab total seconds, as opposed to just the seconds part of something larger. So I'll grab the total, scroll down a little bit, seconds. And to begin with, I'm going to leave it with this alone. We're probably going to end up needing some more control. I'll leave it at just doing the sine over time.
Yeah, for those of you that are familiar with sine and cosine, right off the bat, you can probably guess what this additional control that Logan's going to be looking for is. Things like, how about control the frequency or control the amplitude? So, I'll just kind of prepare you for it.
The one thing I do want to account for now is the fact that sine is going to return a double. So if we try to build, we get an error because we're trying to store that double in a float.
And we need to cast it.
Yeah, we need to implicitly cast over to a float.
Okay.
So now if we build, we can store that result in offset.x.
All right. So now we need to do the offset for y.
And that'll be as simple as copying this line, doing the offset for y, except we're doing the offset against cosine instead of sine, so that we get half offset and then a circle instead of a diagonal.
Yep.
All right. That will make our offset. So now all that's left is to apply that offset to our position. So we can say this.position plus equals offset.
And we can do that because both position and offset are vector2s. Okay.
All right. That should have circular motion in place.
All right.
Do you want to fill in the
do you want to put frequency and all? Now we can come back to it.
Sure.
When they see it at first, it's not going to be that impressive. So then we can come in and put some fine tuning to it.
Yeah, some control.
Yeah. Okay. So we'll come back to that. So at this point, that is all of our classes the way that we spec them out back over on the whiteboard. So now we're finally ready to jump back into the game itself and put this all together. So we've got all of the puzzle pieces. Now let's just put the puzzle together. Okay?
All right. And for that, we need to jump over to the main game class. Alright, for the game to work, we need to add a few things. We need to begin with adding a sprite batch, since we're going to be drawing these textures as sprites, and we need something to make the sprite drawing convenient. So I'll begin by giving ourselves a sprite batch for the game. So we'll just define a sprite batch field. We can call it sprite batch.
Okay. Now, of course, this is just creating the variable. We haven't actually created it yet, just as a reminder.
And while we're creating fields, we could go ahead, if you want, set up the rest of the fields, because we can remember things like
enemy
set
speed.
up a speed, an enemy speed, a player speed, maybe even hold a reference to the player itself.
Sounds good to me.
So I'll jump down a few lines so we can add in the speeds. I'll set the speeds just as constants. These will act as kind of settings for the game. So I'll make a constant float for player speed, and we can set that to 5. And we'll also have a constant float for enemy speed, and we'll set that to 2. And in fact, I could probably make that look a little nicer. 5.0f and 2.0f.
Okay.
Just explicitly define them as floats. And then one other thing that would be very useful would be to have, or to remember, a reference to the player itself. So we could make a private player called player.
Now you're going to see that Logan's not going to maintain a reference to any enemies that get added into the scene, for the simple fact that, as we know, all actors get added into our actors list. And we can walk through that actors list and call upon update, and that is a way for us to find all of our enemies and have them update. Player, we're holding a reference for him because, remember, we're going to do the keyboard polling and adjust his position and all that on our own in the games update. Okay, so I just wanted to kind of make that clear while we're doing this. We're holding the player reference, but not enemy references.
Right, we have a management system set up. Inside of, or thanks to that management system, we have enemies that will move on their own, no input required. On the player, though, we'll have to look at the keyboard, read the input, and set the player ourselves.
Precisely. Okay, so now we have that, I guess we can go on down to initialize and actually create the sprite batch.
Right, we need to have our sprite batch set up before we try to use it. So I'll jump down to initialize, so that once we get to initialize, we have a graphics device. We need to feed a graphics device to sprite batch. So we can take our sprite batch and set it to a new sprite batch. Sprite batch requires a reference to a graphics device, which we have now, and we can access as graphics.graphicsDevice. And that will have a new sprite batch ready for use.
Okay.
Let's see. Next, now there's a few directions we can go. We could add in draw, but we need our actor list for that.
I'd say just jump on down to load graphics content because it kind of makes sense. There we can go ahead and kick off our player and set up his texture and all in position.
We could do a run through for player. Get the player running, then get the actor list drawing, and then see the player running around.
Sounds great to me.
All right. Instead of load graphics content, if we're loading all content, let's create the player. You'll see why we're creating the player here in load graphics content in just a second. So we'll say a player is equal to a new player. What is a player? Well, it's an actor. Actors take in textures. Where do we get textures from? Well, we get them from the content manager. And you see, just from creating the new game, we have a content manager available that is getting created along with the game. So we can access that as content.load. We need to tell it what type of content we're loading, and this is going to be a texture 2D. And then we need to specify the asset itself. So I'm going to specify this as textures, and then whichever asset is.
Yeah.
So over here we have textures and then player. So I'll access the asset named player. And that takes care of adding the texture, so the closing parenthesis for the player's constructor, and then terminate the line.
Okay.
And again, I'm getting the player is called player.png here, but if we look at the asset name, it's player.
That's right.
So that's where that goes for the texture. All right. And with the player, I guess we could go ahead and offset it a little bit, throw it closer to the
just so it's not a
screen.
0, 0.
Right. So while we're in here, we'll take player, we'll set his position to be a new vector 2, and then maybe throw him 300 pixels onto the screen.
Okay.
All right. Well, now that we have an actor, because just the very act of creating him should add him to the actors list, now we should have an actor that we can move around and draw.
That's right.
To begin with, let me do the drawing first, just
Sure.
so we can see something, and then we'll add in the control.
Okay.
So I'm going to jump all the way down to the bottom of this game class where we have our draw method, and we can go ahead and put in some of the necessary sprite batch stuff. before we go trying to draw actors, since actors will actually use the sprite batch to draw, we need to tell the sprite batch to begin before we start using it for drawing. So we'll take our sprite batch and tell it to begin. I'll just let it use default on that.
And you can go ahead and throw the end in as well.
And then tell sprite batch to end. Oops.
Hey Ed, how's it going?
So our sprite batch beginning and ending. So between the begin and end we can draw whatever sprites we want.
Right.
For that we have an actor list that we can look through. So I'm going to loop through all of our actors in the list. And I'll do this with a for each loop. So we can say for each actor in, now this is referencing the actor type object, so actor dot actors. If you remember, we have the static actors list which resides in the actor class. So this is where we actually go to look up all actors. And then we'll use the for each to loop through each one, store it in actor, so that as we're going through the loop, we can say that whatever actor we're looking at, tell it to draw. Draw takes in a sprite batch.
Yeah, we need to send a sprite batch.
So we'll send it our game's sprite batch. And it should be able to draw itself. So we go through all actors, draw them, and the sprite batch, and everything should get displayed.
Very nice.
So I'll build, make sure that there's no syntax errors, and everything succeeded. So let's run and just see if we get some kind of result.
And there we go. We have a player. Like I said, these graphics are quite sophisticated. There's our player, and he's offset 300 by 300 and just sitting there. We don't have anything to drive him yet. He's just being redrawn over and over and over and over and over real fast right now. So I guess we can go ahead and visit update now inside the game. And
matter of fact, just because of the exciting graphics that will be coming along for enemies,
okay.
I'm going to change the background to black,
all
just because that's how I had the setup when I made the uber exciting graphics.
Okay.
So, all right, this is where we stand. One player on a background.
All right, very nice. So let's go ahead and jump on up to update. Let's get it to where you can make him move around with the keyboard.
Okay. All right, so I'll jump up one method up to update. Inside of update, it's keyboard input that's going to drive the player. So the first thing I'm going to do is set up a keyboard state so that I can look at that to look for keys. So I'm going to define a keyboard state variable. I'll call it keyboard state. And change the naming a little bit. All right, keyboard state, and that is going to be equal to keyboard. So we use keyboard to access all keyboard input, but instead of reading keys directly off of the keyboard object, instead it has a get state. So basically lock everything into a state all in one statement. So now we look through the keyboard state to look for specific keys. So we have our keyboard state set up. Now, the idea here with the player is, in a way that's similar to the enemy, I want to come up with a direction for the player to go, and then influence that direction based on what keys are pressed. So I'm going to set up a vector2 called direction, and just like with enemy, initialize that to 0, so it's vector2.0. This way I already have a good base, well, no direction, but set to 0. Now I can just add on to whatever X or Y, depending on keys that are pressed.
Sure.
So the next one we'll do is start to look for keys. And we'll do this with some simple if statements. We can say if keyboard state dot is key down, and then give it some key. Keys are held in the actual keys struct, so we have keys dot, well, let's look for up. We'll do up, down, left, and right. So if keys up is pressed...
So if he's up, we're going up in Y, which means you're going to be subtracting away from Y.
Right. So that means from our direction, which is currently 0 by 0, we could say that direction.y, decrement it by 1. So now that would tell it to move up by 1.
Okay.
And then it's the same idea for the rest of the directions. And with that in mind, I'm going to copy both of these lines and then paste them in 3 more times. So there's 4 keys we're looking for. I'll change the keys to down, keys dot left, and keys dot right.
Fix that R, yeah.
There we go. Alright, so keys dot down, we need to increment Y. Keys dot left, we need to decrement X. And keys dot right, we need to increment X.
Okay.
And this should give us a direction that points in a specific direction based on the keyboard. Though there is an interesting speed thing, I'll leave that in for a minute though until we actually see the player moving.
Okay.
Because now that we've set up a direction, we can just increment the player by that direction. So we can say player dot position plus equals direction. Now, direction is just basically going to be a value of 1 in any direction.
Right.
So we need to use that player speed constant that we define. So that makes the player speed adjustable. So I'll multiply the direction by player speed so that we can have a value greater than 1.
Okay.
And with that, let's see, player position.
That should
work for the player. So let me build, no errors. If we run, then we have our player. So if I start using the arrow keys, I can move up and down, right and left. So everything seems to be working.
Ooh, did I see a diagonal in there?
Now, watch what happens when I apply diagonal. So in each of these cases where we move in only one direction, we're moving at a speed of, well, direction times 5.
Yeah.
But the idea is that the direction is 1 and down, 1 and up, 1 and left, 1 and right. What happens when we introduce diagonals? So like up and left, watch the speed change.
Yeah, you take off.
It's as though we accelerate every time we're on a diagonal. Well, in this case, if we go up and right, so we have a speed of down and right, 1 and 1. So what's actually happening is if you take the magnitude of 1 and 1, it's actually closer to 1.4.
Mm-hmm.
So it's like our speed increases to 1.4 because we're combining the directions. So we're actually making that vector have a higher length in that direction. Now, we can fix this if we wish, and we can actually fix it relatively easily. We can use the same idea that we'd use with the player's speed, the enemy's speed compensation. We can take the vector that we end up with and normalize it. Though we have to be a little bit careful in this case because we don't want to attempt to normalize a vector of 0, or we'll end up with a result that's not a number. So we want to make sure that before we attempt to normalize, that we actually have some direction in place. And we can do this by saying if direction.length is greater than 0.0f. So if we have some value in any direction, then we know that we can go ahead and normalize. Because if it's already 1, normalizing isn't going to affect it. If it happens to be greater than 1, then normalize will pull the values back until the overall value is 1.
And just in case you're still having a bit of a problem with points and vectors and where the heck does length come from and normalize and things like that, please keep in mind there's a big difference here. When you were dealing with points back in, well, way back with the very first iterations of Canon and all, we were just dealing with more or less a simple struct that contained like an X and a Y. Now it's no longer just two numbers that we're dealing with, but vectors come with all sorts of great behavior, if you will, thanks to the Microsoft framework. So in this particular case, a vector does have a length, as you've heard Logan already talking about it. So while we do have a float for X and a float for Y, we now have things like the ability to calculate the length of it, to normalize it, etc.
Right, and the vector object gives you access to functions that will give you all of those values and apply normalization.
It's a vector. That's right.
All right, so a quick test of this to make sure that, all right, that's what we use for reference speed for one direction. If we combine directions now,
yeah, it feels normal.
We move in that direction but retain a speed. So that way we can guarantee that our speed is always set by the speed constant.
Very nice.
Now with that gives us our simple keyboard input for player.
Wow, I guess all we need now is to get some enemies in there.
All right. Well, to make some enemies, let's jump back to load graphics content.
Okay.
And let's make a new enemy. In this case, I'm not even going to have a reference. So without any reference whatsoever, I will begin with new enemy.
Da-da-da. There we go.
An enemy is going to take in a texture. Well, we can do a content.load, and because I'm suddenly feeling lazy, I'll just copy this. So I'll copy the content.load statement, paste that in, and change the actual the asset that it's looking at to enemy.
Okay.
All right, now that would satisfy the first parameter. Next will be the target. Well, we want it to chase the player. So I'll put in the player target. And finally, we need some speed, and we had defined an enemy speed, so we'll plug that in here in the constructor.
Okay.
So end off the parenthesis, end off the terminator, and now we have a new enemy. We're not storing a reference here, but enemies are actors. Actors get added to the actor list. So if we jump down to update now, just after the player's position is updated, we could do something similar to draw. We already have draw set up to look at all actors.
So he's going to get drawn.
So yeah, as a matter of fact,
yeah.
If we run now, there's our our enemy.
Now, of course, you can move around.
So I can move around, but our enemy is failing to chase us. This is because we're not updating the enemy. So now if we look at update, we're setting the player's position, and we're doing nothing with actors. No actors are getting updated right now.
Again, we get to turn our attention back to the power of having an actors list now by simply walking through the list and telling every actor to update.
So once again, I can accomplish this with a for each loop. So I can say for each actor in actor, so the actor class dot actors to get to the list. So we can say every actor tell it to update. Now, update takes in game time, again, for the timing in drunken enemy. And where does game time actually come from? If we look at update, update is actually being fed in a game time. So we simply pass that down the line into update. So we'll give it game time.
Again, just so that we have a changing value that we can use for driving a drunken enemy's sine and cosine.
All right, well, let's go ahead.
And that's all he had to add, and look at this. Here he comes.
Now watch the enemy. So as I move, enemy changes direction. And he smoothly moves in a direction, basically in a straight line towards my current position. So as I run around the screen, we have one enemy chasing the player.
Very cool.
So yeah, well, we know we have that drunken enemy class, and now that we have things able to be created and used easily, let's throw in a drunken enemy. Let me go all the way back to load graphics content. I'll copy the line where I was creating the enemy, paste it into a new one, only for this line, I'm going to create a drunken enemy. Alright, so and same thing. I'm not storing a reference here in load graphics content. We'll simply rely on it to get added into the actors list. Though I will change its texture to be drunken just so we can see the, just so we can tell them apart.
Yeah, we will, though it should be pretty easy, especially once we start tweaking things in just a second. Now, through the power of inheritance...
So there we go. You can see we have two enemies that are both generally chasing the player, but one is doing so more efficiently while the other one is kind of moving in circles along with the chasing action. Which is kind of cool. If we turn off the main enemy, then we get to see a little bit more of the drunken behavior, because now we know what it's supposed to look like, and it kind of meanders off to the side, slows down, speeds up, goes in the wrong direction. All kinds of interesting stuff.
But we can exaggerate this effect by adding in a frequency and an amplitude that we can pick on.
All right, that's a good point. Right now, we have somewhat drunken behavior, but we have no control over how drunken the enemy is.
That's right.
So if we take a look back at drunken enemy, we see that all we're doing is basically getting a 1 to -1 value off of sine and cosine.
Right.
And it would be nice to be able to increase that, increase the amplitude overall. Another thing that would be useful would be to increase the frequency, so how quickly it's progressing over time. We could add some type of factor into that as well.
So basically, how fast we're going to go round and round in circles, and how big is our radius of the circle going to be?
Right. So I don't want to get into putting those into the constructor and having even more things we have to feed over them. For now, we'll just say that we have drunken enemy as a single behavior, and I'll define its parameters with constants. So we can make a private constant float for frequency.
Oh, yeah, and if you guys are experimenting, I mean, you're wanting to play around, experiment with making random or something, so that you could have random frequencies and amplitudes.
Make them random, make them set by the constructor, so you can have control on a per drunken enemy basis.
If you want it that way, that's right.
And let's see, so we have a frequency, we also need an amplitude. And I'll begin with amplitude at somewhere 1.5. Really, with these values, just giving some values other than 1 so we can start to see a different effect. Now, we need to take our frequency and amplitude and apply them to sine. We want to apply amplitude to the overall result. We don't want to affect how quickly it moves in circles. We want to affect how wide the circles are. So I'll apply amplitude outside of the game time. So after we've determined what the sine value is going to be, we'll then turn around and multiply that by amplitude. Now, frequency is going to control how quickly we progress over time. So I'll multiply time.total seconds by frequency. So this way, if frequency is a higher number, it will look like time is increasing more quickly to the sine function. So if we had set it to 2, which it is, actually, yeah, it's set here. So that means every value is going to be twice as fast, and it will look like time is progressing twice as fast, and we'll move in circles faster. All right. And now we need to do the same thing to the other direction, so I'll multiply our cosine values by frequency and by amplitude, so that we have both of them being controlled by our frequency and amplitude. Now we can build, everything builds, we can run, and there we go. We have an enemy that more quickly speeds up, but then slows down if I can catch him at the right speed, moves to almost nothing, moves faster. So a much more drunken-like behavior.
Did you comment out the other guy?
Yes, the other one.
I didn't even see you comment him out.
The other one still commented. I'd done that just for just to see the drunken by himself.
I got you.
If we want, we can go back into the game and bring both enemies back in.
Sort of good for not paying attention. I love how he just sometimes it almost looks like he just stops. It's just because of the combination of everything that's taken place.
Right. His direction towards you wants him to move in one way, while the circular motion's trying to make him move in the other.
So he definitely looks like he has a personality all of his own.
Though with the other enemy in, you can almost start to see the circular behavior. Since the one enemy represents proper tracking, the drunken enemy runs in a circle around proper tracking, and that's basically what he's doing with that enemy.
That's right.
But yeah, I mean, that's all working very nicely.
Okay. Well, I believe this is pretty much everything that we set out to accomplish at the beginning. The idea was just to put together a very simple, I know this was simple, guys, XNA application that demonstrated the use of a static actors list for managing all actors in the scene. And we've kind of been building up towards this as we've been progressing through the last few videos. And we also wanted to make sure that we demonstrated static constructors and that we actually saw inheritance in use. And inheritance and polymorphism is being used, in an intelligent way here. We have an enemy that is able to take on a different behavior, but is based on a behavior of an ascending enemy. So it's really cool stuff. So, and everything is basically being derived from an actor. So, Logan, is there anything you want to add to this?
So really, it's just a good example of showing, well, first, how to manage fields and properties and such, so that we have everything that's common back up at actor. So an actor is a definition for what we want to have as game items. But then we add all of the specifics into classes that start to make more and more sense. So things like players, enemies, and then after that, drunken enemies. And again, setting up putting ourselves in a scenario where in certain cases it takes relatively little amount of code in order to adjust the overall behavior.
That's right.
And all the while keeping all the code very clean and organized, so that from the game everything is looked at from a very high level. We just have players and enemies, and they can be moved, updated, and drawn. But then we get more specific into exactly how actor stores some of its stuff, how it draws itself. And then we get into things like enemy, where enemy has a few additional fields and then does something specific in update. It seeks the player. Then we have a drunken enemy that further extends enemy and adds the drunken circular effect.
Okay.
So all of this done in a very clean and organized manner.
Okay, so at this point, make sure you guys have a very solid, or at least as solid as you can gain at the moment, understanding of everything that we've shown in Object-Oriented Programming 1 and Object-Oriented Programming 2, because we're about to move into the knowledge review, and this will be your first serious knowledge review where we are looking for you to create, well, something that's very real world or can be used in the real world. And more on that in just a few minutes. So with that, that is going to wrap up this video. Thanks a lot. That's it.